I'm one of the early employees at MarkLogic. I joined 16 years ago, before we had any customers or anything. And I just thought this is a really cool piece of technology, and I've really enjoyed my time here. And I've done things from the sales side to the consulting side and whatnot. And the security aspects I find especially interesting. And so I've sort of double-clicked and triple-clicked on this. Today's talk's about 30 minutes, I'd say. Let me just do one thing there. Today's talk's about 30 minutes, and we have an hour. So at the end, you can discuss that roundtable format. If you have a specific question about some technical topic here, and you don't mind it going into the recording section, then just feel free to ask it as we go along, and I'll pause after the major sections for that. Sound good? All right, so our agenda today is broken into 4 parts. I'll start off with just the background of data security and how we think about it. And then I'll talk about some of the core MarkLogic security features, how we do role-based access control, and how we do encryption, things like that. And then I'll move into the more advanced options. The advanced options are really where it gets into secure data sharing, things like redaction, where you can share and suppress some secret data or scramble some secret data, some PII data, and external key management, a fancy security model designed called Compartment Security. And we'll end with some of the standards and certifications that are relevant here. And these days, security has really hit the news. Look at these headlines here. You know, British Airways is fined a couple $100 million. Equifax, $650. We all got our piece of that. Remember when you could sign up to get your $125? Marriott, 123 million GDPR fine. So GDPR especially put some real teeth into data security issues. And when you look at this, you think, how can you do better? What went wrong with Equifax? And I'll get into that, so that they could have to pay so much money for a data breach. And how could they have designed their architecture more securely? And one of the issues that you see is people think firewall, right? And a firewall, you protect your perimeter, that crunchy outside, and you try to keep bad actors from getting on your network. This is good, but it's not enough. I mean, yes, obviously first step, but Capital One data breach, this was that the hackers figured out how to get through the firewall, and then they're able to get all of the data. You have to protect in depth. You can't just protect on the outside, right? You don't just have a castle with one big outside wall and nothing on the inside. And it's the same with data security. You can do application security. With application security, this is like where the middle tier, maybe the Java program, Node program, maybe it has godlike powers. And so it imposes the security rules, and this is just maybe subservient to that application tier. But that introduces its own issues as well, because if someone can breach that application tier, now they get all the data, and all the protection that you wish was present is gone, because they can get the credentials of this godlike middle tier. And that's exactly what happened with Equifax. It was an Apache Struts flaw. If we remember Apache Struts, Java framework for web framework, it had a bug. They were slow to patch it. And so they were able to get full access to the middle tier. From that, they were able to get all the data. The data didn't protect itself. And that's a bad design, I'd say. You want to avoid that. So what we think we should do, besides the other two, is protect the data at the core in the squishy middle, have the data declaratively say who should be allowed to see this, who should be allowed to edit this, who should be allowed to do something with the data. That way, you're protected not just from someone who pops through your firewall, someone who gets onto your application tier, but also the insider threat, right? You have a lot of employees who would already inherently be inside the firewall, who would have access to the application server developers. How can you protect the data even from a developer who's a bad actor, has been compromised? And that's what we're going to talk about today, security model to approach that, okay? So let's get going. These are the core features I'm going to talk in the next section. One is the idea that you want to be secure by default. For example, when you install MarkLogic, the first thing that happens is you have to set up an admin username and an admin password. Some other databases say, well, for simplicity, let's start with without any credentials. And you should read the instructions and learn to add credentials. And we all know what happens after that is you have thousands of instances of such databases on the internet wide open. And we blame the administrator, saying, well, you should have read the instructions that said that you'd add a password. But I think, couldn't they have done secure by default, that the paved path, the common path, is secure? And so we have that throughout everything here. I'll talk about some integration that we have with LDAP, Kerberos, SAML, role-based access control, securing down at the element level, auditing, and encryption. So let's think first about access control. And when you're doing access control, you answer these questions on the right-hand side. Who is this user? And where do I keep my list of users? And how do I verify that the person who says they're this person truly is this person? And then once I know that this person is so-and-so, how do I know what they're allowed to see and what they're allowed to change, what they're allowed to do? And can I restrict this so that certain more sensitive data, more sensitive access can be limited to special users? And all this comes under the 3 A's, authentication, authorization, and auditing. And we'll start off with the authentication section. This is, how do we recognize who you are? How do you prove who you are? Who's this? Or like new phone, who dis? And there's 2 ways of keeping a list of users with MarkLogic. On the left, we have internal authentication. With this, MarkLogic is a database which contains a database of users. When you install MarkLogic, you get a handful of users out of the box, like an admin user, and you can log in with the classic web tech like Basic Digest or Web Form. And you need this to bootstrap. You'll want to keep this as a fail-safe should the external fail, and you need to go and administer it. But what we recommend is that you use external authentication in an enterprise deployment, maybe internal for a demo, internal for a developer, external for the production. And with external, you keep the primary user list external, like in an Active Directory system, maybe in a Kerberos system. And MarkLogic integrates, and when it gets the credentials or a ticket, it interacts with that external user list to say, hey, I just got these credentials, I just got this user name and password, please verify it for me. And you can also do the same with SAML or X509 certs. When you do this, you get seamless integration with the existing enterprise security model. If an employee is added to the database, the LDAP database, then they get access according to the group roles that are present in the system. If the employee leaves, they're immediately revoking access. With internal authentication, you have to do a synchronization, and that can be a little bit more cumbersome. So we recommend the internal auth. Second part of it is authorization. We know who you are at this point, but I need to be able to figure out what you're allowed to do. So what people can do what things. Access control, RBAC. We didn't invent it. It's very common out there. The idea is that you don't give users capabilities, you give roles capabilities, and you assign users to roles. Smith. John is in a sales role, and the sales role, as we see in the middle, is a child of the employee role. And so John, by nature of his role, is allowed to do salesy kind of thing. If John moves to marketing, he gets to marketing type things. Some of the privileges that the database could give him would be to add a customer, generate an estimate. So you can use built-in privileges like reboot a cluster, or you can create extended privileges and assign those privileges to roles. So anyone who's going to add a customer better have the sales role. Same for generating an estimate. Then when it comes to documents, documents give permissions to different roles. I'm using an eyeball to indicate read and a pencil to indicate write. This order doc has assigned itself, basically when we loaded it, we gave it these permissions. An employee should be allowed to read it. A sales role should be allowed to read it or edit it. Sales inherits the read from the employee. So this way, you don't have to have every document say, here's the list of 1,000 people who should be allowed to do something. The order doc just says people of this role should do this, should do that, and then you have a second level of indirection. Here it is visually. We have a wide variety of documents in the database with different read permissions, write permissions. Some documents only have read. There's one document there that doesn't have any read or write, which is allowed. An admin user would be able to administer it, but no one else would have any rights to it. So if John comes along, logs into the database, does its John's external authentication to figure out, prove that you're John. Yep, we trust that this is John, and John has this purple role. Then when John interacts with the database, you can see the documents highlighted, which are the documents that John is able to see, as well as some things John is able to do. John, by being in sales, can create a customer and generate an estimate. Make sense? Jane comes along, and Jane has some different roles. Looks like teal and pink. So the combination of teal and pink are the set of documents that Jane is able to view and able to edit, as well as some of the powerful things Jane's able to do. It looks like the teal is a lesser admin, which has the rights to back up a database, and pink is a very powerful one, which has the ability to reboot the cluster. So Jane has privileges that John lacks. Make sense? Now, in reality, there's more than just read and write. There's actually read and update, node update, insert, and so you have the ability to say, maybe you can insert a document but not change it. So sometimes that's useful. You have the ability to execute it if it was a script, since scripts can be held in the database, things like that. But I'm just simplifying it here for the read and the write. Now, that works pretty well, but sometimes you have special needs. What if some parts of a document are especially sensitive? Think PII, right? Social Security number kind of thing. Can we control who can see that or who can update that? And just that part, not the whole document, but just the section of a document. And if we do that, can we do it efficiently? What I showed you so far is all done out of indexes. So when a user logs in, we have a special index that knows everything that that role is allowed to see, and we can intersect that index with all the rest. So there's no after the fact filtering on imposing your view. So if you're only allowed to see 10 documents, it's very efficient because we can immediately isolate down to those 10. We don't have to after the fact kind of filter through the documents that match to search. And that's a core MarkLogic thing, is everybody with a different security domain should get a really great performance. Can you do this, and can you do this efficiently? And the answer is yes. It's a really great feature called element level security. Sometimes we just shorten it to ELS. You can specify a path to any element or an XML or JSON documents in MarkLogic. It can be an arbitrary path. Something as simple as //SSN says any SSN element anywhere in any document. I want that to be protected, and you can assign which roles to see that element and everything under that element, or to edit that element or everything under that. If the user doesn't have the rights to see it, it's like it doesn't exist. They fetch the document, it's just automatically removed from the document when it's given to the user. They wouldn't even know it's there. And this too is done straight out of the indexes for maximum efficiency. And if you're interested, at the end, we can talk about role sets, which is how this works. If you're thinking you might use ELS, you create a thing called a role set. And we can talk about that later. I don't want to talk too much about it right now. Some of the things you could do, though, like you could do any element or any element probably with XML that has an attribute secret on it should be considered secret. And then at that point, anywhere in any document that you just add a secret attribute, that will apply, and that element will get special security. That's really cool, right? You don't have to upfront even specify where it will be. An XPath, that would be // square bracket secret equals true and square bracket. Something like that would say, anytime you see that, make this secret. You have to have the secret role to be able to do that. And so here we have Jane. We're going to document. Jane can see this full document. There's these special sections here, and to see those and edit those, you have to have the right roles for the element level security. But if we switch to John, John doesn't have those. John's purple, and purple can't see those. From John's point of view, that part of the document just isn't there. I think that's really cool. And it gets to a philosophy around security that you want to fail safe. You want it to be that if you forget to apply the security rules, you should see less data, not more data. Because if you've all seen, a new developer comes along, the new developer creates a new endpoint, which retrieves a document, sends it out. Oh, I forgot to add the part that removes the sensitive stuff, right? Oops, major fiasco. What you want is that the new developer who forgets to do something says, there's parts of this document missing. Oh, right, I forgot to do the right thing that gives me the credentials to see that, right? The person who's calling my endpoint can have the right roles, therefore the parts that are secret don't get sent out, right? And the person has to add a bit of code to see the data rather than add code to suppress the data, because developers will make a mistake. The person who wasn't around during the security design will not be aware that, oh yeah, every time you do that, you're supposed to suppress it. Please never forget. That's a bad design. And so I really like element level security because it makes it easier to fail safe. The whole security model is that, which is the secure by default. Now, all that has been knowing who the person is and what they're allowed to do. Now let's talk about auditing. Auditing is about taking the actions done by people who were correctly at the time authorized to do it, and making sure that no one's getting out of their swim lane, doing things that are suspicious. Or if they're known after the fact to be a bad actor, to be able to reconstruct a timeline and say, so what did that person see? What did that person do? All right. And we can know like who added a document, what they did, what they changed throughout everything. And all that's the third A, which is the auditing. What happened exactly is what we're trying to address with auditing. And so MarkLogic has a built-in auditing feature. There's a wide variety of events that are built in that you can turn on to be audited, and your application can add its own as well. So if there's an application level event that you want audited, you can say, audit this anytime that happens. And some of the things you can do, a document gets inserted, document gets read, document gets updated, certain code executes, an authentication success, but especially an authentication failure, configuration changes, things like this. And so this all gets written out to an audit log file. And I'll talk a little bit later about how to secure an audit log file so that someone who is doing something wrong can't go in there and edit after the fact, cover their footprints. But the idea is that you have an audit log file that can be examined to say what happened when on the whole system, and that can be very important. With something like Edward Snowden, one of the issues was that they knew he took data, but they didn't know what, because the person responsible for the audit and as sys administrator, you imagine how blind you were. Oh my gosh, this guy was a bad actor. What did he take? We don't know. No idea. Could be the crown jewels, maybe not. You have no idea. Everything's suspect at that point going forward, and you want to avoid that. Auditing is a good way to avoid that if you can construct it so that you audit and that the audit can't be tampered with. Exactly about tampering and exfiltration of data is the next section. So you want to prevent someone going around the database and hitting directly onto the file system. Being able to read the data off the file system where it's stored without having the database credentials. Or even worse, someone modifying the files that are on the database, on the file system of the database, to synthetically insert data without going through the database code. Or someone going after the fact and erasing the audit record. How do you prevent that? The answer is encryption. Okay, so encryption, we recommend everybody turn this on. Right? It's built into the core product. There's not to. It protects against insider threats, prevents tampering, and lets you do all these stringent security standards and sort of get those certifications that are required. If Equifax had this, they would have been safe, because someone who was able to get file system access like the attackers did would have said, great, I have scrambled data there. This isn't going to help me any. And so here's how it is visually. And we encrypt on the wire between hosts, from the host to the public network, of course. But I think it's more interesting to focus on the encryption at rest, the encryption on the disk. On the left side of the diagram, we have a person with file system access. And why do they have file system access to the database? Maybe they're the system administrator. Maybe they're the cloud provider. Or maybe they're an attacker who was able to get through your firewall and get through your application tier. That person can just copy off the files install them on another MarkLogic system somewhere, and read them as if it was their own database. Or if they're creative, they could start with another MarkLogic system, create some data, and copy it in place. And this database would trust it and say, oh, looks like I have some data here, right? That's dangerous. Turn encryption on. What you want is someone with file system access to be blocked, so that if they try to see the data, it looks like gibberish. If they try to insert data, it doesn't decrypt, just looks like gibberish again. Because without the right keys, you can't encrypt it in a way that would be decrypted properly. And so this is very valuable. This is very important. Turn this on. If you take away nothing else from today's talk, turn on encryption. It's easy. You can encrypt the data. You can encrypt the configuration. You can encrypt the logs, like the audit logs. You can do just one of the three or two or all of them. Sometimes the configuration might be sensitive. Sometimes it might. Then don't worry about encrypting it. The logs, like the audit logs, maybe you want to encrypt those. Then an administrator couldn't after the fact go in there and edit them. And it's easy. It's just a radio button, at least for the built-in one. With external key management that I'll talk about later, you have to do more. But why not turn it on if it's as easy as a radio button? And it's fast. We're using the latest Intel chipsets that have have ASIC capabilities to be able to do encrypt on chip. And so the era of slowing down significantly because of encryption, that's over. You get very minimal overhead by turning on encryption. All that is built into core product, available without extra. The things I'm going to talk about now, these three things, are part of the advanced security license option, which you can add on to a core license. Redaction, external key management, compartment security. And they're all really focused on being really the best at secure data sharing. So let's talk redaction first. And this addresses sharing information. Can I get a with all the personally identifying information removed? Should be able to. Can I give data to data scientists safely so that they don't get all the data, but they can do their work? Can I get realistic data for a QA or user acceptance environment? Better be able to do all these things. And the way to do that is with redaction. Redaction lets you suppress or scramble sections of a document on export. Okay. So here I have a document, Paul Jackson. Paul's a customer with a phone number, social security, etc. I can pick which XML or JSON fields should be redacted. And I can pick the algorithm of redaction from suppression to something really custom. So simple redaction, you don't get that. This section, when I output it, you shouldn't get it. Okay, that was a social security number. Let's suppress it. But it gets more fancy than that. So here's the original document. Let's do a BI export. So when we're doing a BI export, we'll keep the customer ID as is. We'll suppress the names, they don't care. We'll scramble the phone number to something realistic but fake. We'll scramble the social security number, but in a deterministic way, so that the same social security number that is on the left always becomes the same on the right, so cross-correlation can happen, and I'll keep the city, state, and zip. Okay, but the rest, the address, the name, I'll suppress it. Maybe for QA, well, the QA people, they need all the fields. So for them, let's scramble the first name and the last name and make a fake phone number and mask the social security number so it only has so many digits. Maybe keep the address, city, state, zip. You get to pick, output this, how to output it, suppress it, create random data, create deterministically random data, or mask it. So here's the algorithms you can pick. Simplest is concealing. That means don't output anything. It'll be like it didn't exist, which is different than element level security. Element level security controls what code executing in the database should see. So if you're a developer and you don't have an advanced role, even your code, when it interacts with the database, will not see those properties. Whereas redaction is about an export. So like when you're using MLCP to pull the data out, you can do a redaction. You specify what redaction rules to apply, and then the export will have the data redacted accordingly. So different, right? ELS, the database. Now, if you do an export as a user, which doesn't have enough ability to see some ELS data, well, it's kind of automatically redacted. From your point of view, it doesn't even exist. You wouldn't know it was there, right? Redaction is a different thing. It's about secure data sharing. We have pattern. That's like for social security numbers. You say do hash marks instead of the leading 5. You can do random. Michael Gonzalez becomes Auj Wolfuzu or Jizoff Haifwa. And each time might be different. Just basically scramble it up, make it look possibly a bit like a name, keep it as a string type, but otherwise it's just randomized. I think it's cool that you can do deterministic. With this, the same input always becomes the same output. And that's important because if I'm going to support a data scientist and I'm going to export a couple of different systems to them, I might want the same social security number to always be the same output number, or the same input name to always become the same output name, right? That way they can cross-correlate. And it actually gets even fancier than that. You can provide a salt to this deterministic algorithm, which is a bit of randomness to apply, which controls how this deterministic random output is determined. So if I give the same data scientist different dumps using the same salt, things will be cross-correlatable. If I do it with different, maybe because I'm giving it to different data scientists, then the output will be deterministic within that same salt, but it'll be different between data sets, right? So it's almost like a password on the data by giving a little bit of entropy to the algorithm. So I export A with salt 1, 2, 3, and every time I export with 1, 2, 3, the same input becomes the same output. If I output with 1, 2, 4, completely different output, and you won't be able to cross-correlate with the 1, 2, 3. So that's a really nice feature of deterministic redaction. Dictionary is like deterministic, but you assign the output for a given input. And custom lets you do something like this, where if the birthday is such that the person is a minor, just output minor. Don't scramble it, but do this. And the list of things that you could do, we couldn't think of everything, and so we just gave you custom code hooks where you can jump in and do whatever's needed for your particular situation. Okay. If you have questions on that, I'll take a 5-second pause. So let's think about insider threats, and these are some of the hardest to prevent. What do you do if an AWS or Azure employee desires to see your data and you're hosted in their cloud? Can you prevent the person who runs the box from seeing your data? And to do that, you do external key management with an external key management system. This increases the separation of duties so that the database administrator is not also the security administrator. So you have 2 different roles. Out of the box, the simple approach, the one without the advanced security license option, is a local wallet, and I recommend you at least do this. When you hit the radio button to do encryption, the keys for the files are put in a local wallet. They live next to the data, and they're opened with the administrator account credentials. So if you're not the administrator, you can't see the data, you can't manipulate the data. The database protects itself from the outside world, and you have to be administrator to be able to do things. So that's good. But if you have external key management, then the keys, the encryption keys used to the files, are put into an external key management system. And there's hardware devices that people install, in the rack that manages the keys for the system. And that's run by a security administrator. The MarkLogic admin does not have direct access to encryption keys, right? They're held offsite. And so now we've got a separation of concern, separation of powers. The left, you can see visually, the issue is that local wallet is protected by the DBA credentials. It's good if anyone but the DBA can't get at it. On the right, though, we see that there's a security admin who's running that external key management system. The DBA doesn't get the keys. This is how, if there's a backup done on Tuesday and the DBA is Wednesday, the DBA can't restore it because the DBA, even if they took the database backup, says, I can't decrypt this. Because without the participation, without the continued participation of the external KMS, everything's just gibberish again. If you remove the keys in that external KMS, immediately the database is useless. You know, if you're going to turn in this server, an on-site server, and give it away, as long as you remove the keys from the external KMS, it's gibberish forever, right? And that's very, very useful. We integrate with any external KMS that does KMIP 1.2 or PKCS 11 for the hardware. And so that's a kind of an emerging standard. It's a standard that by now is pretty widely supported. And so we've certified with a variety I'll show you in a minute. Tested against them, made sure that it works really well. And it can kind of seem esoteric. So the way that I think about it, to make it kind of hit home, is we're all used to badging into office buildings these days, right? And in the old days, if you were a trusted employee, you would get a physical key. And you'd be allowed to open up the building in the morning and allowed to close down the building at night. And they trusted that you didn't share the key. And they trusted that if you were let go, that you would turn the key in. And it only worked really for like maybe the outside doors. You wouldn't have a whole lot of inside compartments of your building because, my gosh, you have to hand so many keys to people, right? These days, we give you a badge. And every time you go to the door, you beep, and it goes out to an external system that says, is this person authorized to enter this building at this time, right? And maybe you say at this time of day, no. Maybe this person was let go yesterday, so the answer is no. And I think we've all joked about that, right? Like when the beeper's not working, you're thinking, oh no, what happened to my job, right? Because we're all aware that immediately that external badge management system can turn off my access. So it's that same kind of thing with external key management, right? The physical metal key is the local wallet, where I'm trusted completely and I own the key as well as anyone. Whereas the badge is more like an external key management system in that it's audited. They'll know what building I go into. I can have different compartments within the building, and maybe I can't go in outside of business hours, you name it, right? And that security admin who's controlling who goes where is a separate entity and lets us integrate the key store. Okay, so I think that's an easy way to understand it. It's a more modern and effective way to manage keys. The KMSs that we validated against are shown on the screen. Ironically, the top three are all owned by Thales now. But if you're using any of these five, it works. And Rangan can answer, I think maybe we added the cloud ones now as well. I'll start the question and what we've done with like the AWS external key stores. I'll give 5 seconds for any questions here. Okay. So then now let's talk about compartment security. And this lets you apply really robust security rules. And some of the things it lets you tackle. Can I limit access to people with a certain combined set of roles? Can I construct multiple barriers that you need to satisfy to get access, like a safe within a safe? And my security officer come to me and say some crazy new restriction that I need to impose, and can I impose it declaratively instead of having to write a bunch of code? And so this is the third leg of the advanced security. With standard security on the left, what we talked about already, a user gets access so long as they possess any role that has access, right? If they were pink and there was a eyeball, they could see it. If there was blue and if they were blue and there was a blue eyeball, they could see it. We didn't say you had to have blue and pink. Either one would do. So it's kind of like a safe with multiple doors. If you can open the front or the side, you get access to the data, right? This document says any one of these roles should be able to see me. Fine. Compartment security, you only get access if you possess a role satisfying every compartment. Like a safe within a safe. And it's not enough to just satisfy one, you have to satisfy each. And that really opens up a much richer definition of security policies because it's an and of ors. Each compartment, you have to have one of the ways in for that compartment, but you have to have all compartments, okay? So it's a safe within a safe within a safe. Each safe might have multiple doors to let you access through that safe, but you have to satisfy every compartment, every safe, all the way into the data. Okay. And here's an example, and it was actually really tough to come up with an example that's simple enough to be on the slides, but that was complex enough to not be easily achievable without compartment security. And so for this example, I invented a company that has call center. Any call center would do. And I want to control which people working in the call center should be able to see which documents. And it should be restricted both by job and by country, as well as some policies are sensitive because maybe it's a politician or it's a celebrity, and you don't want just anybody to be able to see those. You have to be a manager or something. You have to be a higher flagged person. Okay, so there's 3 requirements. You have to have a job that's right, you have to be in the right country, and you have to possibly satisfy this special flag, this sensitive flag. Okay, so let's look at some data. Here's a French billing document. To see it, you have to be a call center person or a finance person, and you have to be in France, or at least assigned to France. We have an American policy doc. To see this, you have to be call center or underwriting. It's a policy, not a billing. US, and it's flagged as celebrities. So you have to be authorized to see celebrities. You have to have the celebrity flag to be able to access this document. All right, so first person comes along. Hans is a call center worker in Germany. What can Hans see? Nothing, neither of the docs, right? Has the right job, but the wrong country for the French billing doc. Has the right job, but the wrong country and celebrity flag for the American policy doc. Danielle comes along. Danielle can see the French billing doc because Danielle is a call center worker in the French region. And that satisfies all the compartments for the French billing doc. Cannot see the American policy doc. All right. Mary, call center worker in the US. I can't see any docs. On the French billing doc is blocked by the country compartment, and on the American policy doc is blocked by the celebrity flag, right? Mary's not someone authorized to work on celebrity accounts, therefore blocked on that level. Making sense? This is, and why is this hard to do the other way? Because you'd have to create a rule for like job-country-flag enumerated out for every possible job country, and it's just a combinatorial explosion. And it's very tough to manage, and it's also inefficient at the database level. You want to be able to say, all right, I need to have this compartment, this compartment, this compartment, and you need to satisfy all of them. It comes actually from the intelligence community. This is from the Wikipedia page showing off an example intelligence classification. And to see this document, you have to have all 4. So you have to have top secret as a classification. And then there's a SI special intelligence compartment, which is very restricted knowledge. There's talent keyhole. That's the old satellites by satellite stuff. And it's in the RUFF. So in the talent keyhole compartment with RUFF. And country visibility, no foreign, no professionals allowed to see. And to see this document, then you have to be top secret under VRK in RUFF, and obviously not a foreign national. All right. Who knows if this is a realistic example? It's a Wikipedia example. They don't actually tell us what the real ones are. Does that make sense? That this allows you to have really robust security policies on your data by being able to say, I need a XYZ compartment satisfied completely. An example, the way I picture it from intelligence is, there's a spy satellite that some spy individual interacted with to get us this data. So to know this data, you have to know about both the satellite and the person. If you just know about the person, I'm not going to reveal the knowledge about the satellite. And if I just know about the satellite, I'm not going to reveal the knowledge about the person. You have to know every aspect of how it's data to be able to see the data. That kind of thing is why compartments is so valuable. And getting toward the end, let's talk a little bit about certifications. And there's two halves to this slide. The left is common criteria security certification. So it's an international standard used by governments and other organizations to say, let's figure out some common criteria among us to say, yes, this is trusted. And MarkLogic is one of just 6 database vendors that have it, and the only NoSQL database that has this. And so it's not common because it's easy to get, and it's like everybody has it. It's common because multiple jurisdictions have agreed that this is an important security certification. And it means that your software is built correctly under good management, that the people at the organization at the top levels are trusted, things like that. Okay. And then the right-hand side are some of the ATOs that we have, which is that MarkLogic was deployed in environments that were able to achieve these standards. Because most of these, it's not possible for a database, an RBM file, to be HIPAA compliant, right? Because that's just a technology. And a lot of these are about procedures and plans around security, right? So, but we have deployed in environments, our software has deployed environments which have satisfied all of these. It's like HIPAA's around healthcare data, so we do healthcare.gov, and that's HIPAA compliant. And so the healthcare.gov CMS, people were able to achieve HIPAA compliance using MarkLogic. ICD 509 is an intelligence community directive talking about how classified data should be managed. You need that to run on secret or above networks. FIPS is about security algorithms, that none of the weak algorithms are used if you're in 140-2. SOX is Sarbanes-Oxley. And so that's about internal controls and procedures for financial reporting and external audit. So encryption and auditing is very important for that. The NIST 853 is for things like HIP and FedRAMP. It's a really tough one to get. They should have given it a better name for how difficult it was to achieve. FedRAMP you see a lot, obviously for federal cloud deployments. RAMP is Risk and Authorization Management Program. FedRAMP Medium is the one that most people go for. It's what we are doing with our DHS service, our Data Hub service, because Data Hub service has the ability to be certified because it's a service, not just software. SSAE 18 is about auditing, and of course GDPR, which is the European Data Protection. That's the one where a lot of these fines were coming. If you have European customers, you want to focus a lot on GDPR, make sure that you don't get the hundreds of millions of dollars of fines, and you want to be able to have like the right to be forgotten so that people can delete their data. MarkLogic's very good at letting you, because it's this central hub of data saying remove all data records about this person and satisfying the GDPR needs. And so wrapping up and opening up the roundtable, trust is won in drops and lost in buckets. This is a great quote from Under Armour around the Olympics. Under Armour created some really fancy suits for speed skaters, and then discovered at the Olympics that they really slowed people down. The air vents in the back to let you get rid of sweat created a disturbance in the wind and slowed people down. And so this is what the CEO said, is we understand that trust is won in drops and lost in buckets, so we're going to make it right for everybody out there. And we have a landing page for you if you're interested in all this stuff, marklogic.com/trust.